use slope-intercept form and linear extrapolation. So we're going to take a look at using a real-world situation and creating an equation in slope-intercept form for that equation. I find slope-intercept form is a relatively friendly equation to work with. I find it's the one I tend to use as my go-to. I think of it as a plug-and-play. Slope is right there, y-intercept is right there. I have two pieces of information really sitting right there. They're easy to work with. We're going to take this equation and we're going to see if we can predict what might happen in the future or in a situation outside of the data that we're looking at in front of us. So let's see what this word problem represents. During 1 year, John's cost for self-serve regular gasoline was $3.20 on the 1st of June and $3.42 on the 1st of July. Write a linear equation to predict John's cost of gasoline for the first of any month during the year using 1 to represent January. So the first thing I want to do when I have a word problem is define my variables. And by that I mean I'm going to decide what my independent and my dependent variables are, what they represent, and what letters I'm going to choose to use for them. So in this situation, we're talking about the change of gasoline over time. So we're talking about change over time. So right there I know that the change of gasoline is my y, and the time in months is my x, because our rate is change of y over change of x. So change of gasoline over time, over months. X is my independent variable. I'll know what month it is. Y is my dependent variable. That can tell me what the cost of gasoline is. I'm going to use x and y here instead of using m and g or m and c for cost or dollars or anything like that, to help me kind of remember which one of these is my independent variable and which one is my dependent. My cost of gasoline will be my output in this equation. That is y equals. And my months will be my x value, my independent variable in there. It's going to be my input in this particular equation. So when I look at this as x and y, that really kind of reminds me that I can think about it as an ordered pair or a point on the graph. So I can write the information I know as ordered pairs. They told me that in June, the cost of gasoline was $3.20, so I can write an ordered pair to represent that. And they told me that in July, the cost of gasoline was $3.42, so I can write another ordered pair to represent that. And once I start to see this, I realize, oh, wait a minute, I know how to find an equation from 2 points. Like, I can do that. We've done that before. So let's take those 2 points, and we're going to start by finding the slope. I'm going to use our slope formula. I'm going to take my first ordered pair, plug it y on top, x on the bottom, subtract, again, take my second ordered pair, y in the numerator, x in the denominator, do my math. I come up with a slope of 22 hundredths. So the price of gasoline is changing at a positive rate. It's increasing at 22 cents per month. So let's take that rate of change, that slope, and plug it into my slope intercept form where my m is. So this is starting to look like my equation. I'm just missing my y-intercept here. So to find the y-intercept, I'm going to take one of these ordered pairs. I just chose the first one. I'm going to plug it in for y and x. I'm going to do what I know how to do here with the algebra. And I come up with my y-intercept is 1 and 88 hundredths. So I plug that back into my equation. My equation is y equals 22 hundredths x plus 1 and 88 hundredths. So this means that I have a rate of change of 22 cents per month. My gasoline is changing. My starting point, if I think about January is our month 1, December would kind of be my month 0, where I started this whole change going on. So it was $1.88 before we got to January. All right, what are we going to do with that equation? Because it really makes sense for us to use it for something. This linear extrapolation uses a linear equation to predict values beyond the range of data. So we have a set of data. We're going to look at numbers that are outside of that range. That's our extrapolation. Here's our question. On average, John uses 25 gallons of gas in 1 month. He budgeted $100 for the month of October. Use the equation to predict if John will have to add to his budget. So we're going to drag our equation from our situation into this. I'm going to use 10, since we're talking October, so I'm going to plug 10 into this equation. And I come up with $4.08 as the cost per gallon in October. That's a seriously steep increase in gasoline prices. So October, it's $4.08 per gallon. He uses about 25 gallons of gas per month. So when I look at that, he's going to spend about $102 for his gas in October. He only budgeted $100, so he's going to have to add to his budget. Not a whole lot, but he's definitely going to have to add to his budget. So we were able to use this equation to predict what might happen in the future.